Inverse variation and exponential graphs. Y'all say hi, third period. Hi. All right, so here we go. We're going to get started. I want you to pause this and see if you can write down any of these answers right now. Okay, now we're going to check this to see how you did. What type of equation is it? Inverse variation. Whoops. Inverse variation is when you have two things that multiply to give you one number. Okay? Is it a function? There are two reasons that it's a function. Passes the vertical line test. X's are all different. Can you write it in function notation? That means you have to write it as f of x equals. So that f right there is supposed to remind you f of x. You're going to have 4 questions on your test that say function notation. 4 questions. One's linear, one's quadratic, one's exponential, and one's inverse variation. So I need to solve for y. So what do I divide by? X. So f of x equals 16 over x. Do you want to get that right? Yeah. It is a function. And function notation is 16 over x. Shh. What is the x-intercept? None. It doesn't have one. Do you remember this graph? We did this a few weeks ago. It's going to go something like this. Somebody told me it looked like a butterfly. The word inverse variation has 2 words, and this graph has 2 parts. Okay, what's the y-intercept? None. It doesn't cross the y-axis. So it's none and none. All right, let's try the next one, and we are going to graph this. The only way in your life you know how to graph this right now is to make a table. So can you think of a whole bit? Y'all can flip it. You can go to the graph. It's okay if it messes up a little bit. I need to make a table. That's the only way I know how to do this right now. Can you think of things that multiply to give me 16? I'm going to be organized and start with 1. 1 times 16, 2 times 8, 4 times 4, 8 times 2, and 16 times 1. So 116 is up here. Hey, what's the starting point for this graph? 16. Doesn't have one. Doesn't have a y-intercept, right? Okay, 2, 8. So over to 2 and up to 8. Oops, I think I just missed it. Four, 4. Oh my gosh. Oh my gosh. Oh, what did it just do? 8, 2. And 16, 1. Now, I know your graph doesn't go out to 16. And then connect your dots. Be very careful when you connect your dots. What should it never touch? The x-axis or the y-axis. Also make sure that your graph goes out forever and doesn't start to go back up. Don't be lazy and go like that. Okay? You don't want it to come back up here. That's wrong. All right. Now, I know there's another side to it, so what do I have to do now? The negatives. The negatives. So I can go -1, -16, -2, -8, -4, -4, -8, -2, -16, -1. I'm going to pause this to graph these. So now we have it graphed. Now we need to talk about what the domain and the range is. The domain. Now, we've been saying all real numbers. Listen. For the domain, is it everything or is there a whole? What is the only x value that is not represented here? 0. So our domain is going to be all real numbers, but x cannot equal 0. You're going to have to write it down just like that. X cannot equal 0. This is called a restriction. When you get to Algebra 2, you're going to see a lot of these restrictions. Okay? The reason that x cannot equal 0 is because in function notation like so, can you divide by 0? You can't divide by 0, so that's why we have to say x cannot be 0. All right, my range is going to be all real numbers. And what about the y values? What's the only y value that y is not? 0. So y cannot be 0. Okay, so take this graph, take this equation that's up here, and I want you to write down as much information as you know right now. Okay. All right, what type of equation is it? Exponential. Specifically, what is it? Expo. Is it a function? Yes. X's are all different. Passes the vertical line test. Function notation. What are you supposed to remember? F of x. This is the same. That's easy. F of x equals 7 times 2.5 to the x. What's the x-intercept? None. It doesn't have one. Remember, it never can touch the x because it's exponential. Okay, and the y-intercept is 7. This 7 is your starting value. So it does have a y-intercept. What is the growth factor? 2.5. Okay, now we're going to go to the graph side of your board. So flip your board over, go to the graph side. Now on this, you can make a table if you want. You don't have to make a table if you don't want. So it's kind of up to you. You're going to use your little blue calculator on this. My graph is going to start at what number? 7. So put your dot at 7. Now, the value 1, I have to take the 7 and in my calculator multiply it by 2.5. I can do it in a table over here if you want to, but you don't really have to. My graph starts at 7. 1 gives me what? Okay, so 1 gives me 17.5. So I go over to 1 and up to 17.5. That's going to go way up here. All right, now I'm going to do 2. So I take 17.5, multiply it by 2.5. Do you want to do it? Okay, so that would be 43.75. Now I can't see it, so I'm not even going to write that one down. If I wanted to, I could go backwards in my table and go -1. So I would take 7 and do what with 2.5? If I go down, I'm multiplying by 2.5. But if I'm going backwards, I'm dividing by 2.5. So what is 7 divided by 2.5? 2.8? Okay, so let's graph. I could go back again, but I think I have an idea of what's going to happen. So -1 gives me 2.8. And I can see what's going to happen right now. Whoa, that was bad. Is this very similar to inverse variation? Except it has a starting point. It has a y-intercept, but it also has no x-intercept. The domain is there. If I do a line's going down, 1 to the left, 1 to the right, I hit arrows on both sides. So what is my domain? All real numbers. -infinity to +infinity. But my range, I do rivers, and right here, it looks like it's going to hit 0, but it never hits it. It's always above 0. So my range is going to be y greater than 0. Now that's the first time ever in your whole algebra life that we haven't put the line underneath it for domain. Okay, why am I not putting the line underneath it? It gets really close to 0, but never touches the 0. Okay? All right. Okay, so now we're going to go in our workbook. Page 78, I think we've actually already done most of it, but we're going to talk about it again. On 86, we're going to do 1 through 6. But I need you to answer the domain and range for every single graph that you do.